Okay, so in this lesson, we're going to find the midpoint of a segment where two endpoints are given for a line segment. So for example, we have this segment here, and sometimes your textbook will call it a line segment, but let's just call it a segment that has these two endpoints. So notice it's not a line, so there are no arrows or a ray. It's a line segment. And so you want to find the midpoint. The midpoint meaning, remember we're talking about midpoint. So the midpoint, think middle. So it's the point in the middle of the segment. So if you look at this, at the way it's situated, you can tell that the midpoint of the segment, the point that's in the middle of the segment, is this point here. So and I'm going to call this M for right now. So it looks like this point M divides this segment into two equal parts. So this part, if you look at this length, that's the same length as this one. All right, and our goal is to figure out, well, how do I determine this midpoint? And so we want to use a formula for this. And we want to use what's called the midpoint formula. And so before we look at the midpoint formula, let's go ahead and have this discussion first. Okay, so first of all, if this point right here is 2, let's say my x-coordinate is 2, and I'm looking at this segment right here. All right, so I'm going to go ahead and make it a little bit darker. So let's say that on my x-axis right here, I have this segment. And let's say that this coordinate on the x-axis is 2, and this coordinate here is 8. Can you tell me what you think is the number that's in the middle of these two? All right, so if you said 5, you're correct, okay? Because if you think about it, when I go from 2 to 5, I'm going 2, 3, 4, 5. So that's like 3 units, right? And then from 5 to 8, so that's 5, 6, 7, 8. So that's another 3 units. All right, so that is correct. Now, remember, though, when we think midpoint, I want you to think about this. When we think midpoint, middle, that's the average. Think average. So the average of those two endpoints right here, remember average, you add them and then divide by 2. So that's 10 divided by 2, which gives me 5. So when you think of midpoint, when you think of middle, think the average. All right, think average. And the same thing could occur on the y-axis. So if I look at a segment that's strictly on the y-axis, let's say here, I'm looking at this segment right here, and let's say this point here is, and it's not scaled, so it's not going to look very well, but let's say this is 4, and this is, let's say, 12. Okay? 4 and 12. Can you tell me what you think will be the point or the number that's right in the middle of 4 and 12? Okay, so if you said 8, you're correct. So 8 is correct. Because if I go from 4 to 8, that's 4 units. And from 8 to 12, that's 4 units. So 8 is in the middle. So that distance is the same as that distance. Okay? So remember, think average. So if I were to average 12 and 4 together, that gives me 8, because 12 and 4 is 16, and 16 divided by 2 is 8. Now what I want to do, though, and it's not scaled right, so it may not look very well at this point, but do you agree that this point here, right here, is 2, 4? Okay? And do you agree that this point here, 8, this point right here, so I'm going to have to make sure it's where I want it to be. So this point here is 8, 12, right? Okay? And if I draw that segment right here, what point do you think is in the middle right here? What point do you think that is? All right, well, so if you look at your x-axis, y-axis, to get these coordinates, I said 2, 4, right? And if I did this, I said 8 what? 12, correct? So if I use that same thing here, I'm going to get 5, 8. So this is a point 5, 8. And so remember how we got that 5, 8. So we got the 5 by taking the average of those x values, 2 and 5 added together is 10, 10 divided by 2 is 5, and we took the average of the y values, and we got 8. So on a so if you have a line in a plane and you want to find the midpoint, then all you do is take the average of the x coordinates and then take the average of the y coordinates. So 8 plus 2 is 10, 10 divided by 2 is 5, 12 plus 4 is 16, 16 divided by 2 is 8. Okay, so that takes us now to this situation we had earlier. So real quickly, can you tell me the midpoint? Sure you can. You can tell me the midpoint just by intuitively looking at this. So this is the point 1, 2, and this is the point, what is that 7, 8? So the midpoint is the average of the x coordinates and the average of the y coordinates. Now remember, the midpoint's a point, so you must list it as an ordered pair. You must list it as an ordered pair. So 7, so the x coordinate will be 7 plus 1 divided by 2, so that's 8 divided by 2, which is 4. So that's going to be the x coordinate of my midpoint. The y coordinate of my midpoint will be 8 plus 2, remember the average, so that's 10 divided by 2, which is 5. Okay, so that's the point in the middle of that segment. So that's a point that divides the segment into 2 equal parts. And so you can tell that it is 4, 5, because 4 right here, and then 5. Okay. Now what we want to do though is look at the formula. How do we come up with the formula though? All right. So here's the situation. So we're going to look at 2 points in a plane. Notice that the x and y axes are not numbered. Okay. So that's the reason, because we're going to use the notation that's used in the formula. So let's say this point right here, I'm going to call this x value right here x1. So that's my first point. So first point, so see I'm using the number 1, so that's the x coordinate of the first point. So x sub 1, that's a subscript. And let's call this y value here y sub 1. So the coordinates of that point is x1 comma y1. And let's say this point here, right here, let's call that, and make sure it's right underneath, so let's call that x2, and then the y value will be y2, right? And so I get x sub 2 comma y sub 2. Okay, so what I want to do is look at is come up with a formula for finding the midpoint of this segment. Well, the coordinates of the midpoint, y'all agree, is going to be whatever this x coordinate is right here. All right, and the y value of the midpoint will be whatever this y value is right here. All right, so going back to what we talked about earlier, to get this, we take the average of these, right? So that's going to be x1 plus x2 divided by 2. Do the same thing here, so that's y1 plus y2 divided by 2. And that's the coordinates of the midpoint. So to find the midpoint, we say we add the x's together, so x1 plus x2 divided by 2, comma. Don't forget to do parentheses because it's an ordered pair, it's a point. And then do the same thing with the y coordinate. Okay? And so that's the formula for midpoint. So the formula for midpoint is you add your x coordinates together, take the average, and then here you take the average of the y coordinates. So you add the y's together, divide by 2. Okay? So now let's look at some problems dealing with this. Okay, so first thing you got to remember though is the formula for midpoint. So the midpoint of a segment with endpoints, remember a segment has 2 endpoints. We're going to call this the first point and the second endpoint. All right, so x sub 1, y sub 1, x sub 2, y sub 2. So that's going to be the formula for the midpoint of a segment. And we're going to look at these examples. All right, so notice that the first two examples look easy. The next ones, you're like, oh Lord, we have fractions now, and then radicals, square roots. Don't let all that throw you off. You can do that very easily just using prior knowledge. Okay, so let's look at number one. So number one, we want to find the midpoint. We want to find the midpoint of the segment that contains these two endpoints. Now, without graphing it, you don't want to graph it. You just want to go and just do it straightforward without looking at the graph. That's the whole point of this. That's the whole point of that midpoint formula, just knowing what the midpoint formula is. So basically, here's how I need for you to do this. So the first thing I would do is I would label these points. Let's say this is my first endpoint. So I'm going to say that's going to be x1, y1. And my second endpoint, I'm going to call this x2, y2. And so then the midpoint, all right, so remember midpoint, think average. So midpoint's a point, so you must have an ordered pair. Okay, you must have an ordered pair. So the x-coordinate of my midpoint is the average of the x-coordinates of the endpoints. So negative 2 plus 6 divided by 2, and do the same thing with the y's. 5 plus 7 divided by 2. And so you need to simplify this, so you got to go as far as you can with this. So negative 2 plus 6 is 4. 4 divided by 2, and then this is 7 plus 5 is 12. So 12 divided by 2, and then go further with this. You need to know that 4 divided by 2 is 2, so you need to simplify whenever you can. You need to reduce whenever you can. So the answer is 2, 6. So that's the midpoint. So if you were to draw the segment, if you were to draw the segment, then what you just found is that the point that's in the middle, the point that divides that segment into two equal parts, is the point 2, 6. So meaning this. So this is negative 2, 5 right here. And this is 6, 7 right here. 6, 7. And then I draw my segment. All right, and so when I draw this segment, then right here, then what I just found, this point I just found right here, 2, 6, that's the point that's going to divide this segment into two equal parts. So this distance is the same as that distance. Okay, so that's what we just found. Okay, all right, now let's look at number 2. So number 2, we have this in number 2. So number 2, you have 3, negative 2, and 4, negative 8, and you want to find the midpoint. All right, so straightforward. You remember just the average of the x-coordinates, the average of the y-coordinates. That's the point in the middle. So the midpoint will equal. So you take the average of the x-coordinates, 3 plus 4 divided by 2. Take the average of the y-coordinates, negative 2 plus a negative 8 divided by 2. Okay, go a little bit further with this, simplifying this. 3 plus 4 is 7, so I get 7 halves. And then negative 2 and a negative 8 is a negative 10 halves, right? Okay, so we do expect you to simplify this to reduce this. So you need to recognize that negative 10 halves is a negative 5. So our answer then will be 7 halves, comma, negative 5. Now, if you want to write this improper fraction as a mixed number, you can. Just sometimes, though, students will want to write this as a decimal. That writing this as a decimal is fine because it terminates. So if this was 7/3, you wouldn't want to put this as a decimal. Okay, so I would never write as a decimal unless the coordinates have decimals. So just either leave it as a fraction or as a mixed number, but don't put it as a decimal. So this would be 3.5, comma, negative 5. So either one of those is fine. Does not matter. Okay. All right, number 3. All right, and number 3 is where you start getting fractions. So there are some fractions in some of the problems you may have to deal with. So you need to learn how to deal with those. But those and that's a 5 right here. But those fractions are very easy to deal with. Okay, so remember, you want to find the midpoint of the segment that contains these two endpoints. So again, let's call this x1, y1, x2, y2. And remember, the midpoint is the average of the x-coordinates. Remember, you must use parentheses, so because it's a point. So the average of the x-coordinates. So remember, the x-coordinates are -8/3 plus -7/3. You're taking the average, so you must divide by 2. Okay? You add them, divide by 2, comma. Do the same thing with the y-coordinates. 4/5 plus 16/5. You add, divide by 2. All right, so that's where I'm at. Now we got to do some work here because we got to simplify that numerator as much as possible. So let's think about -8/3. I'm going to go right here and think about this. We have -8/3 plus -7/3. The denominators are the same, so these two fractions have the same denominator. So I can just go ahead and just add them up. -8/3 plus the -7/3. So -8 plus the -7, the signs are the same. And so I'm going to get a negative, let's see, what's that? So that's -15/3. And -15/3 reduced is a -5. So that's this numerator right here. So the numerator becomes -5, and then I'm dividing by 2. Okay, do the same thing here. So I'm going to go off over here and do that. So 4/5 plus 16/5, the denominators are the same. So 4 plus 16 is 20. So I get 20/5, right? Which is 4. So here I get 4/2. Okay, so that numerator is 4. So I get 4/2. But then you want to reduce it just like we did this. I'm going to go ahead and leave this as an improper fraction. It is already reduced to simplest terms. But I can reduce this as 2. So there's your answer. Okay? All right, number 4. Now before we do number 4, let's review something from a previous course. So this is number 4. So this is a review that we're going to need. So remember in a previous course when you had a fraction, let's say 3/4 divided by another fraction, 2/3, let's say. Do you remember how you dealt with this? Do you remember how you divided fractions? So when we divide fractions, we change it to a multiplication problem. And so this right here is equivalent to the following statement. So we take the numerator, which is 3/4, and we multiply by the reciprocal of the denominator. So the reciprocal of the denominator is 3/2. And so I reduce if I can. I can't reduce here, so I'm just going to go ahead and multiply the numerator. So 3 times 3 is 9. And then we'll multiply the denominators. So 4 times 2 is 8. So this right here is 9/8. That's what that is. All right, so same thing if we had, let's say, -3/5 divided by 2. All right, so same idea. You have a fraction divided by another fraction. I mean, I can write 2 as 2/1. And so using this idea, I can change this to a multiplication problem, this division to multiplication problem. So I get the numerator, which is -3/5. I'm going to multiply by the reciprocal of the denominator, which is 1/2. I can't reduce, so I'm just going to go ahead and multiply. So I get -3, because -3 times 1 is -3, and then 5 times 2 is 10. So this right here is this. And the same thing if you had, let's say this. Let's say you had 3 divided by a -2/3. Okay, so 3 divided by -2/3. Well, I have a fraction because 3 is 3 divided by 1. It's equivalent to 3 divided by 1 divided by another fraction. So this becomes 3 divided by 1 times the reciprocal of -2/3. The reciprocal of -2/3 is a -3/2. And so reduce if you can, which I can't here. So I'm just going to say 3 times -3 is a -9. 1 times 2 is 2. Okay, so this right here is equivalent to that. So we're going to need this in the next problem. So let's look at the next problem now. So this is number 4. Okay, number 4, we have this. So we have -3/4, 4/9, and -7/4, -2/9. Okay, so I'm going to label these x1, y1, x2, y2. So it helps if you label these. And then remember, so this is midpoint, so you got to think the average. You have to think average. So midpoint you're going to say, all right, I'm going to take the average of the x-coordinates. So negative 3/4 plus a negative 7/4, all divided by 2. Then I'm going to take the average of the y-coordinates, 4/9 plus a negative 2/9, all divided by 2. Okay? Then we got to work this numerator out a little bit further. We got to go with this a little bit further. So let's go off to the side and see what this is. Now, this is not that bad because the denominators are the same, so it'll make things a lot easier for us. So negative 3/4 plus a negative 7/4, you're adding two numbers, the signs are the same, so you're going to add their absolute values. So 3/4 and a negative 3/4 and 7/4, the absolute values are positive. So 3/4 and 7/4 is 10/4, but you keep the sign. So that's a negative 10/4. Now let's go ahead and reduce this. So when I reduce this, that's going to be a negative 5/2. So that's that numerator. So that numerator here is this. Okay. All right. So I'm just going to go ahead and write it like I have so far. This is what I have. Just go ahead and write it. Don't do too much at once. Do baby steps if you need to. Over here, I have 4/9 plus a negative 2/9. The denominators are the same. I'm adding two numbers whose signs are different. So I'm going to subtract their absolute values. So 4/9 subtract 2/9 is 2/9, and you keep the sign of the number with the larger absolute value. So it'll be this one. So it'll be a positive 2/9. Okay? And so that's the numerator here. But you got to remember that that numerator is being divided by 2. So you don't forget about dividing by 2. Now this right here takes us to what we just reviewed. Okay? So you got to change this. You got to think about this being where you're dividing fractions, you're going to change this multiplication. All right, so let's go ahead and look at this part first. So negative 5/2 divided by 2, negative 5/2 divided by 2 means negative 5/2 times the reciprocal of 2. So I cannot reduce here, so it'll be a negative 5/4. So that's the x-coordinate of my vertex. I'm sorry, the midpoint. So negative 5 divided by 4, comma. Over here, I have 2/9 divided by 2, which becomes 2/9 times the reciprocal of 2. Well, the reciprocal of 2 is 1/2. Now I can reduce here, so I'm going to go ahead and do that. So that'll be, when I reduce that, those become factors of 1. So 1 times 1 is 1, 9 times 1 is 9. So I get 1/9. So that's here. And so there's your midpoint. So that point is in the middle of that segment. Now, let me just mention that, you remember here I reduced first. You could have multiplied first, right? So you could have said 2 times 1 is 2, 9. Let me go ahead and move this up. So 2 times 1 is 2, and then 9 times 2 is 18, and then reduce there. They're both divisible by 2, so you get 1/9. So it didn't matter which approach you use. It's usually easier, though, to reduce first, okay, then multiply, rather than multiply, then reduce. It does not matter, though. All right, so that was number 4. Okay, now let's look at number 5. So number 5, you're dealing with square roots now. All right, so we have 6 comma 4 square root of 5, and we have negative 4 6 square root of 5. Okay. All right. So don't make that don't let that freak you out. You've dealt with radicals in a previous course as well. So you have x1, y1, x2, y2, and again you want to find the midpoint. And so remember, midpoint, you got to think average. So I'm going to take the average of the x-coordinates. So 6 plus a negative 4 divided by 2. And then I'm going to take the average of the y-coordinates. 4 square root of 5 plus 6 square root of 5 divided by 2. All right. So dealing with the x-coordinate here, 6 and a negative 4 is 2. So I get 2 divided by 2. Here I have 4 square root of 5 plus 6 square root of 5. So those square roots are like terms because the radicands are the same. So 6 and 4 is 10, so this becomes 10 square root of 5 divided by 2. Now simplifying this, we now know this. 2 divided by 2 is 1. And then 10 divided by 2, remember this, 10 square root of 5 divided by 2. So 2 goes into 2 one time, 2 goes into 10 5 times, right? So that's going to be 5 square root of 5. So that's your midpoint. Okay? And then number 6, if you look at number 6, you have the square root of 24, comma, negative 3. And the other endpoint is 4 square root of 6, comma, negative 9. Now, the problem here is this. So some of you are going to go and you're going to say, all right, I know I've got to take the average of the x coordinates, and I've got to take the average of the y coordinates. Okay, but here's where you're going to make your mistake. So you're going to say, all right, so when I take the average, I'm going to have the square root of 24 plus 4 square root of 6 divided by 2. And then you're going to leave it like this. You don't leave it like this. You got to remember something that you learned in previous courses, that I can simplify the square root of 24. All right, so that's what you want to do. So first of all, you want to simplify the square root of 24. So let's go off to the side here and remember how to simplify the square root of 24. So when simplifying square roots, you're looking for the largest perfect square that goes into 24, into that number. So the largest perfect square that goes into 24 is 4. So I can write the square root of 24 as the square root of 4 times the square root of 6, because 4 times 6 is 24. And now the square root of 4 we know is 2, so this becomes 2 square root of 6. And notice this now is easy to deal with because that has square root of 6 here. Okay? All right, so you got to remember how to simplify square roots in some of these situations. So everything you've learned in the past, you can't forget about it. You use it at some point in the future. Okay, so the midpoint then becomes, all right, so the square root of 24 is this, right here, 2 square root of 6. So I add the x coordinates together, so I'm finding the average. I'm going to add those together and divide by 2. Okay, just like this, comma. And you do the same thing with the y coordinates. So negative 3 plus a negative 9 divided by 2. Well, just like in the previous problem where we had 4 square root of 5 plus 6 square root of 5 is 10 square root of 5, same thing here. 2 square root of 6 plus 4 square root of 6 is 6 square root of 6. I get 6 square root of 6 divided by 2, comma, and the negative 3 plus the negative 9 is a negative 12 divided by 2. And so simplifying this, 6 divided by 2 is 3, correct? So I get 3 square root of 6, and then this is negative 6. And so there's your midpoint. Okay? All right, so this lesson dealt with finding the midpoint of a segment using the midpoint formula. All right, so that will be the end of this lesson.